Okay, so today I'm going to explain the synchronous counters, the repeating counters, and how to design them. Today's count, we're going to have 1, 3, 5, 1, 3. The things you need is JK flip-flops, you need a truth table, and you need the JK excitation table. Okay, so the first thing is that this was given to you guys. This was the table that was created to color code to see what's going on. This is the present count. So this should be filled out from 0 to 15, and that's just regular binary numbers. The next set is your next count. Okay, if you notice, when we start to fill it out, it's color coded. So these two go with this. These two colors go with the next two. These with this one, and these last go to these two to fill out the table. Okay, so the present count is the count that you're on. The next count is where we're going to. With this particular one, we're going to be using 11 and 9 because we need 2 1s and 2 3s. The Q4 is not going to be wired up, but logically we're going to use them in the K-maps and to fill out this table. Okay, so we're going to count 1, 3, 5, 1, 3. But in reality, we're going to be counting 1, 11, 5, 9, and 3. 11 is going to be used as 3, and 9 is going to be used as 1. Because we're not using the Q4, for instance, this 9 is 1, 0, 0, 1, but because we're not using it, this 9 is actually going to be used for 1. 11 is 1, 0, 1, 1. If we don't use this, it's going to be 0, 1, 1, which is a 3. So the first one we go to is 1, because that's the present count. We're going to start at 1. We're going to go to 3, but we're using 11. Okay? Then the present count would be 11. The next count would be a 5. Then we go to the present count of 5, because after 5, we have another 1, which we're using 9 for. Then the present count is 9. The next count is 3, so we're going to use the natural 3. We go up to the natural 3 present count, and the next count would be 1. And then it's going to go right back where it was. So it will count 1, 3, 5, 1, 3. Okay. To fill this chart out, you need the excitation table, which is this. This is the excitation table. So when you get 0, 0, in the JK, you put 0 and X. When you have 0, 1, put 1X in the JK. 1, 0, X, 1, 1, 1, X, 0 is what you put in JK. And this is where I talked about the color coding really helps. So for instance, when you have 0 and 1, okay, you go to the excitation table, and JK should be 1 and X. The next one is 0 and 0. When you have 0 and 0, then you should have 0 and X for the JK. 0 and a 1 gives you a 1 and an X for a JK. 1 and 1 gives you an X and a 0 for JK. Once this is all filled out, whatever we don't fill in are all don't cares, okay? Then you look down each of the columns. J4, K4, J3, K3, J2, K2, and so on. If you have 1s, 0s, and X's, then you need to do a K map. And that's why I wrote the little K here. If you have X's and 1s, then you tie it high. So K4 is going to be tied high. This is 0s and 1s and X's. So you need a K map for that too. Next one is K3. It's X's and 1s. So that gets tied high. Then we have J2. We have 1, X's, and 0s. So we need a K map for that. This K2 is X's and 1s. So that gets tied high. Okay. Last two, we have all X's. So what does that mean? That means that J1 can be tied high or tied low. It doesn't really matter because it's all X's. We don't care. Lastly is K1. It's all 0s and X's. So that gets tied to 0, which is ground. So that gets tied low. So once you figure all these out, then now you know you need a K map for J4, J3, and J2. Okay, and because it's 0 to 15, you need a larger K map. So the first one is J4. That's J2. Let's look at J4's K map. To fill this K map out, okay, you have to put, when it's 0, when we were going down binary, 0 had an X, 1 had a 1, 2 had a X, 3 had a 0. So you just put the X and 1s or 0s into the numbers. Remember how we fill out these K maps. Then you want the largest group of 1s, and you can use X's. Remember, your groups could be 1, 2, 4, 8, or 16. So here we have a group of 8. Okay, so then you look at Q4 and Q3. Going this way, did they all change? Yes, so you don't worry about that. Coming down, you're looking at Q2 and Q1 now. These two columns only. Did Q2 change? No. Did Q1 change? Yes. So J4 is Q2 not. That's the logic. Okay. J3. You do the same thing. You fill out the numbers and you want to make it so you have the largest group. Well, you can't go this way. You can't make a group of 6. And you can't go this way because you can't make a group of 6. So this is the largest group. You look at 4 and 3, okay? And you're looking at these two columns, okay? So here, did Q4 change? No. But Q3 changed because this is a Q and this is a Q not. So far you have Q4. And then you and it because you're looking at a different one. You look in here now to Q2. Did Q2 change from this to this? No. Did Q1 change? Yes. So the logic for J3 is Q2 ANDed with Q4. Last but not least, we have J2. So we fill in the numbers from 0 to 15. We look this way, okay? So the Q3 on this and this did not change. We have Q4 not, Q4, Q3 not, Q3 not. So that stays the same. When we're going this way to Q2 and Q1, they all change. So the logic for J2 is Q naught 3. Okay. Once you fill them out and you know the logic, we go to the multi-sim, okay? We go to wiring it up. Anything we wire up, we got it because we did the design first, right? But in this one, the only thing you need to know is that preset and clear are both set to high because they have the bubble. Basically, that disables them. You don't wire up Q4 because remember, we didn't really use that. We used it for the logic, but we didn't use it for the count. So this one's Q4, which is the most significant bit, Q3, Q2, and Q1, which is the way we designed it. So when these lights blink, it should be 1, then 3, 5, 1, 3. Remember, we used for J2, we got Q4 and Q2. So this AND gate is going to be Q4 and ANDed with Q2 for J2. So this is kind of important, and you just need to really look at this circuit and see why we hooked up to what we did. And it's because of the design that we used and the plate, the chart that we used, the color-coded chart. That tells you pretty much how everything should be wired. Okay, good luck.